Hello guys. So the topic for this video is electrical corona effect, or maybe you know as corona discharge. Okay, you have seen uh, maybe sometimes while passing through high voltage transmission line you have hear some hissing noise, and maybe you have seen uh, some glow like this. Okay, this we can look. These are actually corona effect or corona discharge. So let's start. So what we'll learn in this video is what is corona effect and how it produce, and what are the disadvantages or effect of corona discharge, and how can we minimize it. Okay, so first of all, what is corona effect? Before okay, let's start. If we uh, go for the definitions, then we have to see it is an effect in which, due to ionization of air around the conductor, a violet glow and hissing noise along with the ozone gas produces. Okay, you can see here some this type of glow. Okay, here in this figure, this glows and it creates some noise, that is normally we say hissing noise. Okay, and it generally seen in transmission line and equipment of 245 kilovolt and above. Okay, when those transmission line it transmit up it can transmit up to like so much higher limit. It has so much higher limit, but when it transfer 245 kilovolt, that time it can be seen. Okay, it can be seen. Normally it occurs with lower than this 245 kV, but it is not visible with the eyes. Okay, normal eyes. Hmm. So how does it produce? Before knowing that, we need to know some things, some important thing like dielectric strength. This one, dielectric strength. So dielectric strength of air is 30 kilovolt per centimeter, or maybe we can call it the breakdown voltage. Okay, air, we know air is normally not pure insulator. Okay, pure insulator means current will not flow through it. So air is not pure leave it. Air is not pure insulator, and breakdown voltage or dielectric strength of air is 30 kilovolt per centimeter. That means if uh, the voltage is 30 kilovolt, okay, in the air, then current will start flowing through it, or the air will start ionizing. Okay, the air will start ionizing. Ionizing means positive and negative. Okay, and one more thing, that is voltage gradient. Okay, we must know this also for corona, that is voltage gradient. Voltage gradient from the figure you can see here, this figure. Okay, this is the figure for voltage gradient. Means suppose this is the conductor. Okay, main conductor, it's supplying 132 kilovolt supply. Okay, with the distance, from the distance of this conductor, the voltage will be like this. Okay, it will decrease slowly. 130 at this area range, it's like we are just assuming, it's not exact, but what is the purpose of this figure is showing that the voltage from this inductor or transmission line is decrease with the distance. Okay, At first 130 first layer, then second layer we are seeing 125, then at last it is showing 120 kilovolt. So actually it is showing only that thing. So this is called voltage gradient, and the value this 120 kilovolt. Okay, suppose here the voltage is more than 30 kilovolt, that we know dielectric strength. So if it is, this is air, okay, this all full path is air, only the middle part that is conductor. Okay, when the dielectric strength we know 30 kilovolt per centimeter, so the voltage when it's here more than 30 kilovolt per centimeter, at that time it start ionizing this air, it start ionizing. Okay, I'll just remove it. Then the distance between transmission line, we have not yet came to the that one, but we are already discussed little bit that why how it is produced. But let's start this, let's go for this also. First, the distance between transmission line, the means that distance between transmission line means, suppose here there is one transmission line, there is another this distance between these two. Okay, this distance, one upside one downside. Okay, this distance between the transmission line is, you can see here, when it is 132 kilovolt, then 2.75 meter, like that. For 400 kilovolt it's 6 meter. Okay, so suppose this is two conductor. Okay, this is one conductor, this is one conductor, this one is another one conductor, it's parallel. Here suppose this first one, this one is number one, this one is number two. Okay, you can see here. Let me just erase it. Suppose we are assuming this one is first conductor, this one is second conductor. Okay, these two conductor, this one is number one, this one is number two. So current following through this conductor. Okay, current is following through this conductor I. In between this, that is air. Okay, and when current following through this, we know it create flux. Okay, surrounding it. And if we just don't want to go for flux, then we can see here, this is the conductor, but voltage around this conductor is the, means voltage is also there. Okay, within the air, but it slowly decrease. Okay, with the distance. So when it cross this 30 kilovolt per centimeter in this air, so then it start ionizing itself. Okay, if it is lower than 30 kV per centimeter, kilovolt per centimeter, within this air here, then it is okay. Normally that time air work as insulator, but when it cross 30 kilovolt per centimeter, the voltage here, okay, then it started ionizing itself and current started following through it. Okay, it's not at that high voltage but lower, but still current is following through it. That because of that, or maybe we can say the ions, those positive negative ions they create here. Okay, here all so many positive and negative ions they created by this effect, and they got a motion. Okay, they itself got a motion, they produce motion. So because of that, that hissing noise and that glow we have seen in the previous figure, this figure. Okay, those glow came. So by like this, this corona discharge or this corona effect is occur in the transmission line. Okay, so effect of corona is, look here, this figure it's clearly showing. Okay, this corona effect. Sometimes the full transmission line, this full transmission line become bright. Okay, this not that much visible. Okay, and it depend also on weather conditions also. Okay, weather conditions also one of the effect, that one of the reason for this corona. So effect of corona, it lost power because the air between air lose the insulator property, air lose. Okay, air lose the insulator property, because of that power loss is there. It produce high frequency noise which can interface with the radio and TV signals. Actually it sometimes it interferes with the radio and TV signals. Then it produce ozone gas. Ozone gas, I think you know, you have heard in your school level, ozone gas. So, and how to minimize it? There are lots of like ways, but one first thing is by bundling the conductor, means without using one, sorry, without using one single conductor, they use so many bundle like this. Okay, na? Sometimes it is like that. Okay, you can draw it, leave it. Bundling the conductor, I think you know, so many small conductors, they will with so many small conductors they will make one conductor. That's it. And by increasing the diameter of conductor, they increase the diameter of conductor. By increasing diameter of the conductor also, it can be minimized, this corona effect or corona discharge. And by using corona ring, there are some rings they use. Okay, normally in transmission line, maybe you have seen here, the figure is not that much nicely visible, but there is corner rings are used. Okay, these are insulator, these are transmission line, this is pole. Okay, strain insulator. So that's it guys, and if you have any doubts, please comment in the comment box and subscribe this channel. I used to upload this type of videos and basic electrical engineering conceptual videos in this channel. And my humble request to everyone, please plant just only one tree each Sunday. Okay, because you maybe you have seen this year the temperature of India, wherever you are, it just increase like anything. So the only way to fight against global warming is plant trees. So it is my request to everyone, to my subscribers, to my viewers, just plant only one tree. That Sunday it's maybe holiday for you, so just plant only one tree anywhere nearby your home house. So that's it guys, bye bye.